After the extinction of the dinosaurs 65 million years ago, on land, animals diversified. Many new species came to be. Most of our information about what happens on land happens at higher latitudes, so at places that are not in the tropics. And the reason for that is because the forest in the tropics covers up the rocks, and that's why we don't have a really good idea of what's going on in the tropics, even though we want to know what's going on there, since most of the biodiversity on the planet today is in these very warm tropical environments. And so in the past, you'd think that would also be the case. The Cerrejón coal mine provides us with a unique opportunity to open the window into that past. What was really incredible was that there were just bones everywhere. And you went out onto these large slopes that represented the slopes where they'd peeled back these huge seams of coal. And underneath those seams of coal, you could see pieces of bone absolutely everywhere. And these were bones of animals that had never been seen before. These were new to science. They were all new animals. And there were so many of them. The way we chose to approach that was through what we call salvage paleontology, which we saw this as a unique opportunity to have access to this site, and now we just have to collect everything. So we went in and collected all the bones that we could see, pretty much. We collected, bones from this animal, and right away we started recognizing things like crocodiles and turtles and fish, things that were very easily recognizable. Along with that, we started to collect bones of an animal that we weren't sure what it was. We thought maybe they belonged to some of the crocodile relatives that we were picking up. Once we got those bones back to the lab, we unwrapped them many months later, and it turned out that they were the bones of the giant snake, Titanoboa cerronensis, the largest snake in the world, which literally at that time represented the largest predator on the planet for probably between 10 and 20 million years. This would have been an animal that, as it was slithering past you, would have slithered by just underneath your waist, and would have been somewhere in the 40 to 50 foot long range. And we didn't recognize them as snakes when we were collecting them initially because they were just so large. It would be like finding the bones of a mouse the size of an elephant. You wouldn't expect to see that. We think these reptiles became so large because it was much warmer in the past than it is today. And so that allowed these cold-blooded animals to become larger than what we see even in the warmest parts of the planet today. By comparison, if you take one of the larger vertebrae from this individual of Titanoboa cerronensis and hold it up for comparison, you can see that this is a much larger snake. This vertebra represents 17-foot long anaconda, as this is a very large snake. And in fact, this is the largest anaconda that we have here in the collections at the Florida Museum of Natural History. And it doesn't look like it would be 17 feet long, but if you imagine that the ribs come off like this, and that this animal would have been something like that big around, you realize this vertebra represents 17-foot long anaconda. This is a very large snake. And in fact, this is the largest anaconda that we have here in the collections at the Florida Museum of Natural History. So this is a very large snake. So if this one's 17 feet long, I don't know, my original guesstimate would have been this one was about 100 feet long. That actually was not correct. But it is much larger than the 17-foot long snake. And you can see, so again, you would have had the ribs coming off, something like that. When we look at the vertebrae of Titanoboa, the shape of those vertebrae tell us that it's related to boeing snakes alive today, things like boa and anaconda. And in fact, it also shows us that it's probably more closely related to boa than it is to anaconda. It's different from boa, though, in the sense that it probably spent most of its time in the water. And we know that based on the internal structure of the bones of the vertebrae, which are very porous as opposed to the denser vertebrae that you see in non-aquatic snakes. We also find it in an environment that preserves other more aquatic types of animals. So in that way, in terms of its ecology, it's more like an anaconda, even though it's more closely related to boa. If you look at the diet of anacondas today, they eat side-necked turtles and they eat crocodilians. And because we find both turtles and crocodiles in the same environment with Titanoboa, it's not a real stretch to say they probably ate those animals as well. If we look at the structure of the skull, it shows us that they had very closely spaced teeth, consistent with animals that were also specialized for eating large fish. So it's also very likely that Titanoboa would have eaten many of the fish that we find in its ecosystem, which include things related to bonefish today and also lungfishes, giant lungfishes.